Combination of resistors. Resistors of all values of resistances are not available. Hence, resistors are connected in a number of ways to increase or decrease the combined resistance. There are two distinct ways in which resistors can be connected. They are resistors in series and resistors in parallel. Resistors connected in series. Resistors are said to be in series when they are joined end to end, so that the same current flows through each one of them in succession. Since there is a single path for the moving charge, the same current must flow through each resistor. Let the conductors AB, BC and CD having resistances equal to R1, R2 and R3 respectively be joined in series, and let the current passing through them be 1. Let V1, V2 and V3 be the potential difference between the ends of the first, second and third conductor respectively. By Ohm's law, V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. If V is the total potential difference between the ends A, D and RS is the effective resistance of the combination of all the resistors, then V is equal to IRS, but V is equal to V1 plus V2 plus V3, or IRS is equal to IR1 plus IR2 plus IR3, or IRS is equal to I multiplied by R1 plus R2 plus R3, or RS is equal to R1 plus R2 plus R3. The above result holds good for any number of resistors joined in series. When some resistors are joined in series, the total resistance is the sum of individual resistances. If n resistors, each of resistance R, are joined in series, then RS is equal to R plus R plus R plus up to n times is equal to NR. Structure of atom. Matter is made up of tiny particles called atoms. Atoms are the smallest particles of matter. Each atom is similar to the solar system, just like the planets revolving around the sun. Atoms are made up of three basic particles called electrons, protons, and neutrons. An atom consists of a heavy central positively charged nucleus, where positively charged protons and neutral neutrons are present. The negatively charged electrons revolve around the nucleus in definite fixed orbits called shells. In an atom, the number of positively charged protons is equal to the number of negatively charged electrons. Hence, an atom is electrically neutral. Charging of bodies. Substances can be electrically charged by friction, that is, rubbing, conduction, and induction. Charges by friction. Rubbing. When a glass rod is rubbed with silk, some electrons from the glass rod are transferred to the silk. Since the glass rod has lost some of the electrons, the glass rod becomes positively charged. At the same time, silk has gained electrons. As a result, it becomes negatively charged. The number of negative charges gained by the silk is equal to the number of positive charges on the glass rod. When an ebonite rod is rubbed with fur, the ebonite rod gets some extra electrons from the fur and becomes negatively charged. At the same time, the fur cloth, which has lost electrons, becomes positively charged. Charges. When electrons move away from an atom, the number of positively charged protons are in excess, and hence it becomes a positively charged body. When an atom gains electrons, the number of negatively charged electrons are in excess, and hence it becomes a negatively charged body. The positively and negatively charged bodies are called ions. The two types of ions are cations and anions. Cations. Positively charged bodies are called cations, which are formed by the loss of electrons. Anions. Negatively charged bodies are called anions, which are formed by the gain of electrons. A glass rod rubbed with a silk cloth acquires positive charge. Whereas an ebonite rod rubbed with a fur cloth acquires negative charge. Like charges repel each other and unlike charges attract each other. A glass rod is rubbed with a piece of silk cloth. The rod is suspended by means of silk thread. Another glass rod rubbed with a piece of silk cloth is brought near the suspended glass rod. The suspended glass rod repels away from the second glass rod. An ebonite rod is rubbed with fur cloth and suspended by means of a silk thread. Another ebonite rod rubbed with fur is brought near the suspended rod. The suspended ebonite rod repels away from the second ebonite rod. The ebonite rod rubbed with a fur is brought near the suspended glass rod. Both get attracted to each other. From this, it is clear that like charges repel each other and unlike charges attract each other. Charging by conduction. Transferring of charges from charged bodies to uncharged bodies by making physical contact between them is called charging by conduction. Take a glass rod which is already charged positively and bring it in contact with an uncharged conductor. They share their charges and both acquire the same type of charges, that is, the positive charge. As the positively charged glass rod touches the uncharged conductor, free electrons from the conductor move to the glass rod as it has fewer electrons. Thus, the uncharged body, that is the conductor, gets charged. In the same manner, negative charges also can be transferred. Insulators cannot be charged by conduction as they lack free electrons. Electric current in a conductor. Some of the electrons are free to move about from one atom to another. However, some outside force has to be maintained to make the electrons move in a specified direction. This force is called electromotive force or EMF. EMF or source of current is simply a device which causes the motion of electrons already present in the wire. It does not produce any electrons itself. Electric current in a conductor. Some of the electrons are free to move about from one atom to another. However, some outside force has to be maintained to make the electrons move in a specified direction. This force is called electromotive force or EMF. EMF or source of current is simply a device which causes the motion of electrons already present in the wire. It does not produce any electrons itself. Volta invented one of the earliest and simple device capable of producing a steady current. This device was later called voltaic cell. Household electric circuits or domestic wiring. Tree system. Electricity supplied to us for domestic purposes is 220 volts and alternating current, that is also called as AC. The current alternates its polarity 50 times in 1 second. Example, its frequency is 50 Hz. The main supply is delivered to houses using a 3-core wiring called live, neutral, and the earth. The live wire is red or brown in color and brings current. It is dangerous to touch live wire with bare hands. Neutral is black or light blue colored wire and is used as return wire. The third wire, green or yellow-green in color, is earth wire. Earth may be taken from pole or a metal plate sunk deep in the earth. It is a safety measure and does not in any way affect the supply. Earth is usually connected to the body of the electric appliances. If at any time the live wire incidentally touches the body of the electric appliance, the earth wire sends the current from the body of the appliances of the earth. All the appliances are connected in parallel so that switching off one circuit does not affect the other section. The parallel circuit also ensures that each appliance is connected to the same voltage. Earthing of electric appliances. In order to work an electric apparatus, we require two wires, one live wire and the other neutral. Due to wear and tear or due to excessive heating, sometimes live wire touches the body of the apparatus. Thus, we get shock when the apparatus is touched incidentally. To avoid the risk of electric shock, the metal body of electric appliance is earthed, that is, a wire is connected to the cover of the vessel on one side and to the earth point in 3-pin plug. One end of the earth point is buried deep in the earth. Earth wire is usually given green-yellow color. The live wire is usually red or brown, while black or light blue wire acts as a neutral wire. Flow of current in a wire. A metal wire has plenty of free electrons in it. When a metal is not connected to a source of electricity, the electrons present in it move at random in all directions between the atoms of the metal wire. Since electrons move in all directions, the net flow of current in the wire is zero. When a cell is connected at the ends of the metal wire, the electric force acts on electrons present in the wire. Electrons start moving from negative terminal to positive terminal of the wire. This flow of electrons constitutes a current. To safety fuse. When current of value more than maximum permissible is passed through the circuit, the fuse wire melts due to excessive heating. This way, the circuit is broken to safety of the circuit. It is due to this fact that the fuse is usually called safety fuse. The thickness, length, and material of the fuse wire depends upon the maximum current permitted through the circuit. For proper protection, a fuse of proper value is a must. Charging by induction. The process of charging a body without actual contact is called charging by induction. If a positively charged body A is brought near a conductor BC mounted on an insulating stand, the end B receives an equal number of negative charges and the end C acquires the same number of positive charges. Suppose the positively charged body A is removed, then the charges redistribute in BC and it becomes neutral again. On the other hand, in the presence of the positively charged body A, if the end C is earthed, the positive charges flow to the earth. Remove both A and the earthing simultaneously. The negative charges at the end B will be distributed uniformly throughout BC and the body becomes negatively charged, which is equal to the same amount of charges on A. Electricity. The word electricity is derived from the Greek word electron, meaning amber. Electricity is of two types. They are static electricity and current electricity. Charges at rest constitute static electricity. Charges in motion, that is, movement of electrons from one place to another place, constitute as current electricity. Magnetic effects of current or electromagnetism. A current flowing in a wire always gives rise to a magnetic field around it. Further, Importance of magnetic field produced due to current passing in a wire lies in the fact that it gives rise to a mechanical force. Electric motor, dynamo, radio, and TV all utilize the magnetic effect of electric current. The magnetic effect of electric current is also called as electromagnetism. Resistors connected in parallel. A circuit in which two or more resistors are connected across common points so as to provide separate paths is called parallel circuit. In this case, the same potential difference will be maintained between the two ends of every resistor, and the current will divide itself in various branches. Let the resistors R1, R2, and R3 be joined in parallel to the points A and B. Let the current I reaching A divide itself into three parts, I1, I2, and I3, along R1, R2, and R3, respectively. Let V be the potential difference between the points A and B. The current flowing in the individual resistors are then given by I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. Let Rp be the resistance of the combination. Then I is equal to V by Rp, but I is equal to I1 plus I2 plus I3, or V by Rp is equal to V by R1 plus V by R2 plus V by R3, or V into 1 by Rp equals V into 1 by R1 plus 1 by R2 plus 1 by R3, or 1 by Rp equal 1 by R1 plus 1 by R2 plus 1 by R3. The result holds true for any number of resistors. Thus, when a number of resistors are joined in parallel, the reciprocal of the resistance of the combination is equal to the sum of the reciprocals of individual resistances. If n resistors, each of resistance is equal to R, are joined in parallel, then 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R plus up to n times is equal to n by R, or Rp is equal to R by n. Electric potential. When a positive charge is placed in the electric field due to another charge, it experiences a force. Work has been done on the positive charge to move it against this force of repulsion. The electrostatic potential at any point is defined as the work done in bringing a unit positive charge from infinity to that point.